Okay, so there's this massive shift happening, all around the world. People are living longer.
Right.
And that brings, well, a growing need for support, doesn't it? For aging populations, for individuals with disabilities.
Yeah, absolutely. We're talking about independence, safety, better health monitoring, big important stuff.
Big stuff. And meeting those needs, it means looking beyond the usual ways of doing things, finding really innovative solutions.
That's right. Which brings us to our topic.
Exactly. So this deep dive, it's all about something pretty surprising. How textiles, the actual fabric of our clothes, are being transformed.
Transformed into intelligent electronic systems.
Yeah, systems designed specifically to help meet these needs in ways that, honestly, sound a bit like science fiction sometimes.
So our mission here is to sift through these sources you've pulled together, focusing on intelligent and e-textiles for adaptive apparel.
We want to figure out, okay, what are they? What can they actually do functionally, like right now?
And importantly, what does the future hold?
Because this isn't just about clothing that's, say, easier to put on. That's kind of what adaptive often meant before.
Right. That was the main focus.
We're looking at a real paradigm shift here towards apparel that's dynamically responsive, that interacts with you, with your environment.
Okay, let's dive in.
Let's start with maybe one of the most immediate impacts, health monitoring.
Yeah. The core idea in the sources is using clothing for continuous real-time tracking of health parameters.
Which really pushes healthcare towards being more preventative.
Right.
Catching things earlier.
Exactly. Catching issues before they become major problems. And what's fascinating is how these textile systems can integrate complex sensors almost invisibly.
Totally. Take ECG monitoring. Instead of sticking electrodes on your skin, which can be uncomfortable.
Yeah, and annoying.
Right. Fabric sensors are just woven right into a shirt. It's a much more comfortable way to get that crucial heart data.
I saw some amazing examples in the sources, like that Health Watch shirt prototype.
Oh yeah, the 15 lead ECG.
15 leads woven directly into the fabric. I mean, a standard wearable might give you 1, maybe 2 leads.
But 15 gives you that really detailed picture of the heart's electrical activity, almost like you'd get in a clinic.
But you're just wearing your shirt? The goal is remote monitoring for things like arrhythmias.
And here's the kicker. They're even designed to be washable.
Which is huge, though still in the demo phase, as you said.
Still demo, yeah. But the research backs it up, right? That getting wet isn't necessarily a deal breaker.
Yeah, one study found these washable, silver-printed textile electrodes. They kept their signal quality pretty well, comparable to standard ones, even after 10 washes.
10 washes. That's a big step for actually using these things day to day.
Definitely. And it's not just heart signals either. The sources mention monitoring other vitals too.
Like what?
Well, muscle activity, stress levels, tracking heart rate variability, which can tell you about recovery or stress.
Oh, interesting.
And even exploring ways to predict heart failure risk. Though that Chimera t-shirt prototype they mentioned seems unavailable now.
Still, the potential is there. And beyond electrical signals, they're using pressure sensors woven into fabrics.
Right, to measure blood pressure. There was one smart t-shirt prototype combining temperature, activity, and blood pressure monitoring.
And crucially, how do you wash it?
Well, they designed it so the electronic bits could be easily removed for washing. That modularity seems pretty key.
It does. And think about monitoring something like sleep or how someone walks.
Yeah, the sleep monitoring with pressure-sensing bed sheets.
You just lie on it.
Pretty much. One study reported over 70% accuracy for identifying sleep stages. And the sources really stress how non-invasive that is compared to, a traditional sleep study lab.
Totally different experience. And for gait, how you walk.
Smart insoles. They have arrays of pressure sensors that map how pressure shifts through your foot as you take a step.
Right, I saw that. And posture, too.
Yes, an intelligent cushion that can identify your sitting position with, 98% accuracy.
Wow.
By analyzing the subtle pressure patterns from your back muscles against the cushion.
That kind of precision, that could be invaluable for preventing pressure sores or just supporting spinal health.
Oh, question. The potential for health monitoring in textiles is just huge.
But okay, let's be real. The sources also flag the challenges straight away.
Of course. Like making sure it's consistently accurate and reliable, out in the real world, not just in a lab.
And making sure the sensors actually survive being washed over and over.
And the huge questions around data privacy and security. This is sensitive health info.
Absolutely critical. And let's face it, cost. Developing and making these high-tech fabrics isn't cheap right now.
True. Okay, so if we zoom out a bit, these textiles aren't just for health data. They can significantly boost safety and communication, especially for vulnerable groups.
Yeah, this is where it gets really interesting, I think.
Think about fall detection, a huge concern for older adults.
Definitely. The sources describe these smart textile systems maybe in vests or shirts using machine learning.
And they can detect falls with incredibly high accuracy, like 98% was mentioned.
But they go further. They can even classify the orientation of the fall.
Into 11 different categories, yeah. Knowing how someone fell gives critical info to caregivers or paramedics about potential injuries.
And these systems can link up to the Internet of Things in a home, right, for remote monitoring.
Exactly. And extending that safety net, these systems can spot sudden critical health changes, maybe a big drop in heart rate, or no movement after a fall.
And automatically trigger alerts.
Yeah, send alerts to caregivers or emergency services. That speed could literally save a life.
Wow. And for communication, there was that smart glove example.
Oh, the sign language translation glove. That was fascinating.
How does that work? Strain sensors.
Yeah, strain sensors on the fingers detect the subtle movements and shapes of hand gestures. It connects to a mobile interface.
And translates American Sign Language gestures into spoken language.
It's a powerful way to break down communication barriers.
Amazing. And beyond translation, the sources also mentioned potential for, like, displaying messages.
Right, using integrated screens like e-ink or LEDs maybe, or even providing haptic feedback, little vibrations for communication or navigation cues.
Okay, so all this sophisticated stuff needs connectivity.
For sure. Those conductive fibers woven in basically act like tiny wires.
Allowing data transmission via Bluetooth, NFC, things like that.
And then there was that really mind-blowing bit about metamaterial textiles.
Oh, right, for wireless communication between implants inside the body.
Exactly. Metamaterials are engineered to manipulate waves, like radio waves. Using them in textiles could be a way to reliably connect medical devices deep inside the body wirelessly.
Which is something traditional radio waves really struggle with.
Yeah, it's really pushing the boundaries of what fabric can do.
And while location tracking is mentioned, like GPS and smart wheelchairs or walking aids,
the sources also raise a crucial privacy point. Even if GPS is off, your location might still be trackable via your phone's magnetometer if it's integrated.
Good point. So privacy is a constant thread here.
Definitely. Okay, moving on to mobility assistance. This is where textiles actively help with movement, provide support.
Right. It's about active functionality, not just passive ease of dressing. The sources describe actuated textiles.
Programmable smart textiles using fluid-powered artificial muscle fibers, AMFs.
Tiny, soft actuators in the fabric.
Exactly. They change shape when fluid or air pressure is applied.
And they allow for pretty dramatic changes.
Oh, yeah. Examples were given like making fabric elongate by up to 65% or expand in area by over 100%.
Wow.
Or bend or create localized compression, like compression sleeves for fingers or forearms using strategically placed fibers.
They even had those bio-inspired examples, taking a flat sheet of fabric
and turning it into something dynamic, like a controllable four-legged structure that could walk, or mimicking butterfly wings morphing, or a flower closing.
Just using these embedded AMS, it really shows the potential for textiles to become active components.
And other applications here include those smart insoles, again, for gait analysis, helping therapists or individuals understand movement.
And intelligent PPE, personal protective equipment.
Right. Wearable computing and smart textiles monitoring a worker's health status in hazardous environments.
But again, the challenge is, how do you power these active textiles?
That's a big one. Traditional batteries are usually too bulky, too restrictive.
And durability, if they're constantly moving and stretching.
Critical. And ensuring they're still comfortable to wear while providing assistance, that's a major design hurdle.
So power. What are the ideas there? Energy harvesting.
Exactly. The sources discuss harvesting energy from body movement itself. Things like triboelectric generators creating electricity from friction as fabric rubs.
Okay.
Piezoelectric materials power from bending or pressure. Thermoelectric using temperature differences between the body and the air.
Even biofuel cells using sweat.
Potentially, yeah.
Cool.
These are all ways to maybe make smart textiles self-powered eventually.
Okay, let's talk comfort. Obviously essential for any clothing, but maybe even more so for adaptive apparel.
Absolutely, especially for people who might have sensory issues or difficulty regulating their own body temperature.
So the goal here is moving beyond just picking a comfy fabric.
Right. It's creating textiles that dynamically adapt to the wearer's needs and the environment.
Like thermoregulation.
Yeah. Smart textiles can monitor body and ambient temperature, then actively adjust their thermal properties, trapping heat or dissipating excess heat.
And moisture management is key too, especially for long wear. We know about moisture-wicking, quick-drying stuff.
But the sources introduce Janus wettability textile.
Janus, like the two-faced god.
Exactly. Inspired by nature, desert beetles, cacti surfaces with different properties. These textiles have asymmetric layers. One hydrophobic, water-repelling, one hydrophilic, water-attracting.
Oh, so it pulls moisture one way.
Precisely. Pulls sweat away from the skin, pushes it outwards to evaporate. They mentioned MVTR, moisture vapor transmission rate.
Right, a breathability metric. A high MVTR, over 5,000 grams per square meter per 24 hours, means it lets a lot of sweat vapor out. Drier, more comfortable.
And for passive thermal regulation, there are phase change materials, PCMs.
Like tiny heat absorbers releasers.
Sort of, yeah, like tiny packets that absorb heat as they melt, release it as they solidify, buffers temperature swings.
But the sources mention limitations.
Definitely. Low thermal conductivity, so they don't move heat fast. Risk of supercooling, staying liquid below freezing point. Leakage risks, added weight and bulk. Environmental concerns with some PCMs, too.
So not a perfect solution yet.
Not yet, but there was that interesting power-free example, the Nephian sheet.
Inspired by skin. With flaps.
Yeah, tiny openable flaps that respond dynamically to moisture and heat changes, venting like pores. Enhances breathability without needing power.
Cool. And they briefly mentioned other comfort aspects, too.
Just touched on tactile comfort, how the fabric feels, its surface and moving comfort, making sure it stretches and contracts well with body movement.
So the overall goal is really personalized climate control, which is vital for people who struggle to regulate temperature or manage moisture.
Absolutely crucial.
Okay. Shifting gears again, rehabilitation and therapy. How can intelligent textiles help there?
Well, the core idea is using them to monitor patient progress, provide feedback, even actively assist with therapy exercises and recovery.
So real-time data capture.
Right. E-textiles with sensors can capture, process, digitize body motion data, invaluable for therapists assessing progress or recovery.
The sources listed some specific examples. Light therapy.
Yeah, light-emitting fabrics for photodynamic treatments, using light to activate drugs for skin conditions or wound healing.
And electrotherapy.
Interactive textiles delivering electrical stimulation. Could be for blood circulation, muscle stim, or accelerating wound healing.
They mentioned TENS again. Those energy harvesting textiles.
Yeah, 10 smart textiles were shown to accelerate wound healing, so the fabric could potentially power its own healing stimulation.
Wow. What about monitoring systems?
Wearable garments, tracking things like lung ventilation during respiratory therapy or continuous cardiac activity.
And those nanomesh transistors.
Tiny, flexible electronics amplifying ECG signals right on the skin, getting really clear data with less noise.
Smart bandages and stockings are evolving too.
Integrating sensors to monitor wound healing directly or actuators for dynamic compression therapy.
And for physical therapy itself, actuators could help.
Provide tactile feedback, maybe a vibration to cue a movement, or even provide some movement assistance, very relevant for stroke recovery or mobility impairments.
And connecting this all allows for remote care. Telemedicine.
Exactly. A therapist could track progress remotely, adjust programs based on data from the smart textile.
There was also mention of advanced wound care, drug-releasing fibers.
Yeah, smart dressings that not only monitor but incorporate drug-releasing fibers or electrical heating for precise, controlled medication delivery. Shown to boost healing, especially for tough cases like diabetic wounds. But again, the familiar challenges pop up. Data security, accuracy, getting widespread clinical adoption, still hurdles.
So what actually makes all this possible? Let's just briefly touch on the enabling technologies, the building blocks.
Okay. At the heart of it, it's the materials, conductive fibers.
Made with silver or carbon nanotubes, special polymers.
Right. Woven or knitted in to create the wiring.
Yeah.
Key properties are conductivity, obviously, but also flexibility, durability. It's always a trade-off depending on the application.
Then you have the sensors and actuators we've talked about. Sensors perceive.
Mechanical ones for pressure strain, biomedical for sweat heart rate, and environmental for temp humidity, and so on.
And actuators do things.
Right. Thermal ones, changing shape with heat, electroactive polymers with electricity, pneumatic systems with air. They enable the shape change, the support.
And nanotechnology, how does that fit in?
Working at the nanoscale adds amazing functionality, like silver nanoparticles for antimicrobial properties, keeping things hygienic.
Or metal oxides for self-cleaning.
Exactly. ZNO, TiO2. And nanomaterials can enhance the durability of the conductive parts, too.
Okay, so we've covered incredible potential across health, safety, mobility, comfort, therapy. Let's pull back and synthesize those recurring challenges.
Durability is a big one, consistently highlighted, making sure everything withstands daily wear, stretching, bending, and especially washing. That's critical.
Cost, another major barrier. High development and manufacturing costs limit accessibility right now.
Power, always an issue. Batteries are bulky, uncomfortable, run out. Finding reliable, comfortable, maybe integrated power sources like energy harvesting is essential.
Data privacy and security. Paramount. We're talking sensitive personal health data. Protecting it is non-negotiable.
User acceptance, too. Functionality isn't enough. It has to be comfortable, look good, not be stigmatizing, be easy to use day to day.
It needs to feel like clothing, right? Not a medical device.
Exactly. And ensuring consistent accuracy and reliability of sensors and algorithms in the real world, that's a huge technical challenge.
Plus, a lack of uniform standards for testing, design, data that hinders things.
Ultimately, tackling all this needs a truly interdisciplinary effort. Engineers, material scientists, designers, healthcare pros, policymakers all need to collaborate.
Looking ahead, though, the future perspectives seem incredibly promising.
Yeah, we can expect continued advances in the basic materials, more durable, flexible, comfortable. Electronics getting smaller, more efficient, more seamlessly integrated.
The intelligence will deepen too, right? More AI and machine learning.
For sure. For highly personalized support, real-time analysis, maybe even predictive capabilities based on your patterns.
Connectivity will become more seamless, integrating with the broader Internet of Things, other assistive tech, creating comprehensive care networks.
And the focus will stay strongly on the user. User-centered design, accessibility for diverse needs, aesthetics, making sure it's not stigmatizing.
And as these techs spread, ethics and policy become vital. Robust data protection, clear guidelines, supportive regulations for equitable access.
Not everyone who could benefit gets the chance. The ultimate goal, really highlighted in the sources, is moving beyond niche uses.
To become fundamental tools.
Yeah, fundamental tools for building a more inclusive society, one that supports independence, dignity, well-being for aging populations and those with disabilities.
So we've really gone deep today into how textiles, something so everyday, are being fundamentally transformed based on these sources you shared.
From monitoring vitals and detecting falls with amazing accuracy.
To actively assisting movement, providing personalized comfort, supporting rehab. The potential is just vast.
It's clear these innovations are about much more than just cool tech and fabric. They're about enhancing lives, promoting independence, fostering inclusion.
Indeed. So what does all this mean for you listening? Consider how these developments in intelligent fabrics might fundamentally change our relationship with our clothes. Instead of just being passive coverings, they could become active partners in our health, our safety, and how we connect with the world. Something to think about.